preparation, properties and applications of a individual polymers like polyvinyl chloride and Teflon. Okay, ma. So first of all, we see what are the topics covered in today's session. So the main topics covered in today's session is we see the preparation of individual polymers like PVC, polyvinyl chloride, and also Teflon. Teflon is also called as polytetrafluoroethylene, and every polymer having its own monomer, and that monomer is undergoes a particular polymerization, depends upon the conditions they give the polymerization products. And after that we see properties. Properties means which explains the strength, toughness of that particular individual polymer. Then based on the properties we explain what are the applications of that particular polymers, either in a domestic purpose and industrial purpose. Okay, ma? So that are the main topics covered in today's session. Okay, let us start with the first individual polymer, nothing but the polyvinyl chloride, PVC, polyvinyl chloride. Okay, ma, all of you visible my preparation slide, ma, PVC preparation slide. All of you visible my preparation slide, Amma?
Yes, sir.
PVC preparation slide.
Yes, sir.
Okay. Okay, ma'am. First of all, let us start with the polymer PVC. So before starting the PVC, first we learn revise the definitions of a polymer and monomer. Okay, ma'am. Polymer is nothing but a long chain organic substance which is formed by the covalent linkage between the monomers, which is formed by the covalent linkage between the monomers. So what is monomer? Monomer is nothing but the basic unit of polymer. Monomer is nothing but the basic unit of a polymer, and which involves the total number of the repeating units present in a polymer. The total number of the repeating units present in a polymer is represented with the letter small n. So where n represents the the total number of the monomers which are involved in the polymerization, reaction. Okay, amma. So where small n represents the how many number of the monomers involved in a particular polymerization. That may be either addition polymerization or condensation polymerization. You must know what is the degree of polymerization. The degree of polymerization takes place with the help of the number of the monomers linked with the covalent bond. And you know about the covalent bond. Covalent bond is formed by the sharing of electron pairs. Covalent bond is formed by the sharing of electron pairs. Okay, now coming to the topic, the individual polymer. That means now the current polymer is the PVC. In PVC, what is the monomer, amma? In PVC, what is the monomer? For example, if you can take as PVC as a polymer, what is the monomer, amma? Monomer of PVC?
Vinyl chloride.
Vinyl chloride.
Vinyl chloride, amma. Very good. So now coming to the point, vinyl chloride is a direct monomer. Vinyl chloride is a direct monomer. For example, if you consider the polymer polythene. Polythene is a polymer. What is the monomer in polythene?
Ethylene.
Ethylene. Now compare the ethylene and vinyl chloride. Out of two, which one is direct monomer? Out of two, which one is a direct monomer? Ethylene or vinyl chloride?
Ethylene.
Ethylene is a direct monomer. Very good. But coming to the point of vinyl chloride is not an direct monomer. It needs some chemical preparation. Okay, ma? Now let us see first of all the preparation of the monomer. Then we move to how to synthesize the polyvinyl chloride. Okay, ma? So first of all, the monomer used for the manufacture of PVC. PVC means the full form is polyvinyl chloride and abbreviated as PVC is vinyl chloride. So in PVC, VC means vinyl chloride that can act as a monomer. And vinyl chloride is not a direct monomer. That's why it is need to prepare before starting the synthesis of PVC. So vinyl chloride is prepared by the treating of acetylene, with hydrochloric acid. Acetylene with hydrochloric acid at 60 to 80 degree centigrade. At 60 to 80 degree centigrade, and in the presence of a metal oxide is used as a catalyst. And in the presence of metal oxide is used as a catalyst. Okay, ma? Now coming to the point. The entire process should be takes place in the presence of a catalyst. And I think you know about the catalyst. Catalyst is nothing but which enhance the rate of the reaction. Catalyst is a substance which enhance the rate of the reaction. So rate means decreasing the concentration of reactants with respect to time, or increasing the concentration of products, with respect to time. Okay, so this is about the working efficiency of a catalyst. Okay, ma? And coming to the point, the vinyl chloride is initially prepared by treating the acetylene with hydrochloric acid at 60 to 80 degrees centigrade, and in the presence of a metal oxide is used as a catalyst. Okay, ma? So first of all, acetylene. Anybody know the formula for acetylene? No, what is the formula for acetylene?
C2H2.
Very good, C2H2. Now see the structure. The structure of the acetylene is CH triple bond CH, and it reacts with the hydrochloric acid. What happens? One of the hydrogen is replaced by the chlorine. So what happens? C double bond C. That means from the unsaturation triple bond to double bond will be takes place. From triple bond to double bond. That means bond breaking will takes place. And The structure is the CH2 double bond CHCl, CH2 double bond CHCl. So it is looks like say the monomer of ethylene. So the monomer like ethylene when undergoes addition polymerization to give a polyethylene. Actually the formula for the ethylene is CH2 double bond CH2, CH2 double bond CH2 double bond CH2. But out of four hydrogens, out of four hydrogens, out of four hydrogens, one of the hydrogen is replaced by the chloride. Okay, so that is the difference between the ethylene and vinyl chloride. The formula for ethylene is CH2 double bond CH2, whereas the formula for vinyl chloride is CH2 double bond CHCl, CH2 double bond CHCl. So this is a vinyl chloride. So this vinyl chloride will undergo say addition polymerization. This vinyl chloride undergoes a addition polymerization to give a polyvinyl chloride. Polyvinyl chloride. Okay, see the product. It is nothing but a CH2 double bond CHCl with n moles. Already discussed about this small n. Small n means, anybody know what is the meaning of small n?
Number of monomers.
Very good. Number of the monomers which are participated in the polymerization. Okay, that is simply called as a degree of polymerization. Degree of polymerization, where degree of polymerization is represented with small n, and the total number of the monomers, the total number of the monomers which are involved in the addition polymerization to give a final product like polyvinyl chloride. Polyvinyl chloride. Okay, and from the starting of the reaction to ending of the reaction, we observe the carbon balance is very, very important. So for example, if we can take as a reactants acetylene, the formula for the acetylene is CH2 triple bond the formula for the acetylene is CH triple bond CH triple bond CH. You see the first carbon, it is linked with the 3 bonds with the carbon and 1 bond with the hydrogen. So the valence of the carbon is 4, and for second carbon also it is linked with 3 bonds and attached with the 1 hydrogen. The second carbon valence is also 4. And the monomeric product, that is vinyl chloride. In vinyl chloride also the formula is CH2 double bond CHCl. So for the first carbon, 2 bonds are linked with the hydrogen and 2 bonds linked with the carbon, and second carbon, 1 bond linked with the chlorine, 1 bond linked with the hydrogen, and 2 bonds linked with the carbon. So for any way, the valence of the at any carbon equal to 4. And final product polyvinyl chloride, that means when vinyl chloride undergoes a addition polymerization, when vinyl chloride undergoes a addition polymerization to give a PVC. So in this case, what happens, the product PVC, there are how many carbons present? 2 carbons are present. For each carbon, it satisfies its valency. That means tetra valency. Okay, so when you write the equations, especially for the polymeric equations, there must be a carbon is there. So at any stage, the carbon must be satisfied with its tetra valency. That means that is very, very important point. When you write the equation, the carbon is satisfied its tetra valency. That means it linked with the 4 bonds. Okay, so that is the important condition when you write the equations. Okay, so now let us see the preparation. That means already discussed about this PVC is prepared by the addition polymerization when the monomer of vinyl chloride undergoes addition polymerization. And the vinyl chloride is not a direct monomer, and it is prepared by the reaction between acetylene, that means CH triple bond CH reacts with the hydrochloric acid at a temperature of 60 to 80 degrees centigrade, 60 to 80 degrees centigrade, and especially should be takes place in the presence of a metal oxide is used as a catalyst. Metal oxide is used as a catalyst. Okay, so this is about the preparation. Next, we see the properties and uses of a PVC. Properties and uses of a PVC. The first one is a rigid PVC. Rigid PVC. So this rigid PVC means basically the substance is a highly stable and very, very hard. and structurally it is very strong, and it is also called as a unplasticized PVC. Unplasticized PVC. That means the resultant plastic is not applicable to molding purpose. So it is chemically inert and non-inflammable powder. And it is chemically inert non-inflammable powder having a high softening point of 148 degree centigrade. 148 degree centigrade. And this PVC is used for making safety helmets, refrigerator components, tires, cycle, and motorcycle materials. Okay, so because of the nature of this PVC, nothing but unplasticized PVC. Unplasticized PVC. Unplasticized PVC means the resultant plastic is not applicable for the molding purpose. So because of the nature of this unplasticized PVC, it is purely chemically inert compound. That means it should not react with any other chemical. And non-inflammable powder. Non-inflammable for having a softening point 140 degree centigrade. Okay, ma. Now everybody visible the unplasticized PVC slide, ma. Rigid PVC.
Yes, sir.
Okay, ma. So rigid PVC. Rigid PVC means structurally it is strong. Okay, ma. And it is also called as the alternative name for rigid PVC is unplasticized PVC. Unplasticized PVC. Chemically, it is an inert and a non-inflammable powder having a high softening point nearly 148 degree centigrade. 148 degree centigrade. And this PVC is used for the making safety helmets, refrigerator components, tires, cycle, and motorcycle materials. So because of the rigid nature of PVC, that means called as unplasticized PVC, absence of plasticizers. Because of the absence of plasticizers, the resultant plastic is not applicable to molding purpose. So structurally it is strong component. So because of this structure, this PVC is used for safety helmets and refrigerator components, tires, cycle, and motorcycle materials. So these are the applications for a PVC. Nothing but unplasticized PVC. And one more PVC is there, that is called plasticized PVC. Plasticizers PVC. All of you visible this slide? Plasticized PVC.
Yes, sir.
Okay, so plasticizers PVC. Plasticized PVC means it is produced by the mixing of plasticizers. Produced by the mixing of plasticizers like disbutyl phthalate with PVC resin uniformly. With PVC resin uniformly. So the main difference between for the current plasticized PVC and previous unplasticized PVC is at the present polymer there is a presence of a plasticizers. There is a presence of a plasticizers. So which plasticizer is used? Disbutyl phthalate. Disbutyl phthalate. Okay, ma. Disbutyl phthalate with the PVC resin uniformly. So because of the presence of plasticizers, what happens? Compounding of the plastic will be takes place, and which improves the flexibility and softness of a polymer. For this purpose, we use a plasticizers. Then only the molding is possible in the PVC. Okay, ma? For the purpose of molding, we add the plasticizers towards that pure plastic. Then only molding is possible. So it is used for making raincoats, tablecloths, handbags, curtains, and electrical insulators, radio, TV components, and all PVC shoes for beach wear. All PVC shoes for beach wear. Okay, ma? So this is about the uses of a plasticized PVC. And tell me anybody, what is the difference between unplasticized and plasticized PVC? Seven 17. Meet yourself. What is the difference between plasticized PVC and unplasticized PVC?
Plasticized PVC it is produced by mixing plasticizers such as butyl palette with PVC resin. Unplasticized PVC means it is non-inflammable powder and inert.
Okay, basically, plasticized PVC molding is applicable, whereas unplasticized PVC molding is not applicable. Okay, ma? So that is the main difference between the unplasticized PVC and plasticized PVC. Okay, ma? Now we see the physical properties of a plasticized PVC. The first one is the density. Density means PVC is very dense compared to the most of the plastics. So generally the density is defined as the ratio between the mass and volume, and the specific gravity around 1.4. And economically PVC is readily available, and it is available in cheap in cost. And next one, hardness. Rigid PVC is very hard. And strength. Rigid PVC has extremely good tensile strength. Tensile strength means the material should be bared by applying very high pressure. That means with high load. So that is called as a high tensile strength. And economical versatile polyvinyl chloride. PVC or vinyl is used as a variety of applications in the building and construction, healthcare, electronics, automobile, and other sectors. So, in products ranging from piping to siding, blood bags and tubing to wire and cable installation, windshield system components, and more. Okay, ma? So this is about the economical properties of a PVC. And next one, there are many uses for the PVC as a rigid plastic. It is used as vinyl siding, magnetic stripe cards, window profile, pipe plumbing, and conductor fuses. And PVC is commonly used as a insulation on the electrical pipes. Okay, ma? So insulator. So insulator means the substance which does not allow the passage of electricity to that particular substance. So for the coating of electrical wires, this PVC is used as a material. Okay, ma. So sorry for the inconvenience, ma, due to Wi-Fi problem. Again, I rejoin. Okay, ma. All of you visible the slide. Preparation of PVC. Emma, all of you visible the slide. Preparation of PVC.
Yes, sir.
Yes, sir.
Okay, ma. ఎవరో హ్యాండ్ రైట్ చేశారమ్మా? సిఆరా? Am I any doubt?
లేదు సార్, బై మిస్టేక్ రీనేమ్ చేసే బదులు హ్యాండ్ రైజ్ అయింది.
Okay. Okay, amma. Now I revise the preparation, properties and applications of PVC. First of all, we see the preparation of PVC. So in PVC, what is the monomer, amma?
Polyethylene.
In PVC, amma, PVC.
Vinyl chloride.
Vinyl chloride.
Vinyl chloride.
Vinyl chloride, amma. Okay, amma. So vinyl chloride, but vinyl chloride is not a direct. So it is need to prepare the vinyl chloride before undergo a polymerization of polyvinyl chloride. So first of all, this vinyl chloride is called as a monomer of PVC. Monomer means the basic unit of a polymer, and it is also called as a repeating units. Okay, ma. The total number of the repeating units present in a polymer is called as a degree of polymerization. Okay, ma. Now vinyl chloride. Now we see how to prepare vinyl chloride. So this vinyl chloride is prepared by the treating acetylene molecule with hydrochloric acid at 60 to 80 degrees centigrade, and in the presence of a metal oxide is used as a catalyst. And in the presence of metal oxide is used as a catalyst. Okay, ma. So first of all, we see acetylene. Acetylene means the formula for the acetylene is a C2H2, and the structure is CH triple bond CH, CH triple bond CH, and it reacts with the hydrochloric acid to give a vinyl chloride. So the structure of the vinyl chloride is looks like a ethylene. So why? Because the structure of ethylene is CH2 double bond CH2 double bond CH2. But the structure of vinyl chloride is CH2 double bond CHCl, CH2 double bond CHCl. That means one hydrogen is replaced by the chlorine. One hydrogen replaced by the chlorine. So that is the main difference of this structure. Okay, ma. And this vinyl chloride undergoes a addition polymerization to give polyvinyl chloride. Okay, so this vinyl chloride undergoes a polymerization to give a polyvinyl chloride. Okay, in the equation we observe there is a small n. This small n represents the degree of polymerization. Okay, tell me what are the reactants for the manufacture of vinyl chloride? What are the reactants for the preparation of vinyl chloride?
Acetylene and
HCl.
Okay, acetylene and hydrochloric acid. And what is the required temperature,
60 to 80.
60 to 80 degree centigrade.
Celsius.
And in the presence of a metal oxide catalyst, this vinyl chloride undergoes which polymerization, amma?
Addition
Polymerization.
Okay, ma. Addition polymerization to give a PVC. And the structure of PVC is nothing but a CH2 single bond CHCl where N moles. N means degree of polymerization. The total number of the vinyl chlorides present in a polymer. Next, we see the properties and uses based on the types of PVC. Okay, ma. How many types of PVC is there, amma?
Two types.
Two types. What are they?
Unplasticized PVC and plasticized PVC.
Unplasticized PVC and plasticized PVC. Okay, ma. Tell me what is the difference between the unplasticized PVC and plasticized PVC? Ma, tell me what is the difference between unplasticized PVC and plasticized PVC?
Unplasticized means it is chemically inert and non-inflammable powder, and
Okay.
it can be highly softened. And for plasticized PVC, it is produced by butylene phthalate with the PVC resin uniform.
Okay, ma. So that means molding is possible out of two in which plastic?
Unplasticized.
In unplasticized molding is possible?
Plasticized.
Plasticized PVC, amma. That is very, very important. So see the plasticized PVC. There is a presence of a plasticizers. There is a presence of a plasticizers like this butyl phthalate. Okay, amma. So because of the presence of plasticizers, what happens? This plastic is applicable to molding purpose. This plastic is applicable to molding purpose. So first of all, we see unplasticized PVC. It is chemically inert and non-inflammable powder. It is chemically inert and non-inflammable powder having a high softening point, nearly 140 degree centigrade. And coming to the such PVC is used for making safety helmets, refrigerator components, tires, cycle and motorcycle mudguards. Okay, ma. Anybody tell me why unplasticized PVC is used like helmets, refrigerator compounds, tire, cycle and motorcycle mudguards? What is the reason? The unplasticized PVC is used for helmets, refrigerator compounds, motorcycle mudguards.
Unflammable.
It is unplasticized PVC and nature is rigid PVC. Why this PVC gets such nature? Emma, why this PVC gets such nature? Because there is a absence of plasticizers. There is a absence of plasticizers. So without plasticizers, the plastic is not applicable to molding purpose and it become a rigid nature. Coming to the second type of PVC, so that is called plasticized PVC. Plasticized PVC. So plasticized PVC means we understood that there is a presence of plasticizers. There is a presence of plasticizers. So that is nothing but a this butyl phthalate. This we say this butyl phthalate. Okay, ma. So because of this plasticizer, what happening? Compounding of the plastic will be takes place, and the resultant plastic acquires the flexibility and toughness. Okay, ma. And this plasticized PVC is mainly useful for the raincoats, tablecloths, handbags, curtains, and electrical insulators, radio, TV components. And all this type of the PVC is used for shoes for beachy. Okay, ma. So entire the application should be depends upon the nature of the plasticizer PVC, because it is formed, it is manufactured in the presence of a plasticizers. So because of the plasticizers, it acquires the that molding nature. Okay, so this is called plasticized PVC and including their applications. Okay, now everybody understood about PVC, amma? Emma, everybody understood about PVC, polyvinyl chloride?
Yes, sir.
Yes, sir.
Okay, ma. And next polymer is the Teflon. Okay, ma. First of all, we see the preparation for Teflon. The alternative name for the Teflon is polytetrafluoroethylene. Polytetrafluoroethylene. So if the name is polytetrafluoroethylene, what is the monomer? Tetrafluoroethylene. Tetrafluoroethylene. Okay, ma. See the structure PVC. Tetrafluoroethylene. So I think all of you know what is the formula for ethylene. What is the formula for ethylene, amma?
CH2 double bond CH.
CH2 double bond CH. So that means ethylene contain how many hydrogens?
4
hydrogens. That 4 hydrogens are replaced by the 4 fluorine atoms. 4 fluorine atoms. 4 F atoms. So it is called tetrafluoroethylene because it's look like a structure of ethylene. So that's why it is called tetrafluoroethylene. 1, 2, 3, 4. That means 4 fluorine atoms are attached to the C double bond C ethylene molecule. So it is called as tetrafluoroethylene. And this tetrafluoroethylene undergoes a water emulsion polymerization. Water emulsion polymerization in the presence of a benzyl peroxide is acts as a catalyst. Then tetrafluoroethylene converts it into a polytetrafluoroethylene. And where observe the for the balance in the chemical reaction, n moles of the tetrafluoroethylene undergoes water emulsion polymerization in the presence of benzyl peroxide is used as a catalyst to get a small n moles of PTFE. PTFE means polytetrafluoroethylene, and it is simply called as Teflon. Okay, so now we see the preparation. Teflon is obtained by the polymerization of water emulsion tetrafluoroethylene under pressure in the presence of benzyl peroxide. Is used as a catalyst. Okay, ma? Again, the catalyst is there for the purpose of to improve the speed of the reaction. Okay, ma? And see the equation also is so simple. You remember the structure of ethylene. Generally the formula for ethylene is C2H4 and structure is CH2 double bond CH2. The total 4 hydrogens are replaced by the 4 fluorine atoms. So that is called tetrafluoroethylene, and which undergoes a water emulsion polymerization in the presence of benzyl peroxide to get a polytetrafluoroethylene, and it is also called as Teflon. Okay, so the alternative name for Teflon is also important, that is called Fluon. Okay, so Teflon is also known as the Fluon. So due to the presence of highly electronegative fluorine atoms, okay, already in the structure we observe the fluorine atom. Okay, tell me out of the entire periodic table, what is the most electronegative element?
Fluorine.
Okay, very good. So fluorine present in which group?
7th group.
And that group is also called as, what is the name of that group?
Halogens.
Okay, very good. So that means the 7th group contains the fluorine, chlorine, bromine, iodine, astatine. So from the top to bottom, what happens? The electronegativity gradually decreases. Okay, now coming to the point, in the Teflon we observe the fluorine atoms. These fluorine atoms are highly electronegative. Okay, so due to presence of high electronegative fluorine atoms, these are strong attractive force is responsible for high toughness and high chemical resistance. Towards all chemicals except hot alkali metal and hot fluorine, except hot alkali metal and hot fluorine. Okay, ma? So this is very, very important. Due to the presence of highly electronegative fluorine atoms, these are strong attractive forces, is responsible for high toughness and high chemical resistance. That means these are chemically inert, and towards almost all the chemicals except only two situations. One is hot alkali metal and hot fluorine. Hot alkali metal and hot fluorine. Okay, so this is about the properties of the polytetrafluoroethylene, Teflon. After that, we see the applications of the Teflon. Okay, uses. So it is used making seals and gaskets which have withstand at a high temperature. So first of all, gaskets. Gaskets are mainly useful for a pressure cooker, and the pressure cooker is maintained at a very, very high temperature. That means boiling of a rice. And for that purpose, the gasket is very, very important, especially in the case of pressure cooker. Why? Because there is no leakage of the vapors coming out from a pressure cooker. So for this purpose, we maintain the gaskets. Okay, so such gaskets or seals are mainly prepared by this Teflon material, and the nature of the Teflon material is it can withstand at very, very high temperature. And second one, it is also used for the insulation of electrical items and for making non-sticky surface coating, particularly for the cooking utensils. Okay, not only in gaskets, it is also used as a insulation material. So because of the insulation, the Teflon material, it does not involve the any passage of electricity through that particular substance. And third one is Teflon. Teflon is used as a insulating material for motors, transformers, cables, wires, fitting, etc. Okay, so for all this purpose, the Teflon can be acts as a insulating material. The Teflon can be acts as a insulating material. So for what purpose? It is insulating material for motors, transformers, cables, wires, and fitting, etc. Okay, so this is about the uses of a Teflon. Okay, so that is overall preparation.
Any doubts as of now?